Hi everyone. The objective for today is to practice using the binomial theorem to expand binomials. It's not always going to be the shortest, easiest, most efficient thing, but it's a really cool way of expanding binomials, and sometimes it is more efficient. So in order to use the binomial theorem, we need a binomial that we're trying to multiply out. And you can do the binomial theorem instead of multiplying 3x squared plus 5y 4 times. So what the binomial theorem states is that if you have a binomial, so some term plus some term to some power, you can expand that using a sum. And the sum, at the end of a binomial, it would be like x squared plus 2x plus 7 or something. That's why it's a sum, because you're adding all the terms together. So you're going to add all the terms, and the way you calculate the terms is using this explicit formula here. So you're going to multiply the combination and choose k. Okay, and you're going to take the first term and raise it to the n minus k, and the second term and raise it to the k. So let's figure out what n and k are to start. Okay, the easiest thing to see is that n is our exponent. So anywhere you see an n here is going to be the exponent of the binomial. Okay, whereas k is our position of whatever term you're talking about. But keep in mind we're starting at term 0 instead of term 1. So let me show you what that looks like over here. To compute the first term of this binomial, you would take n, choose k. So my n is 4. I start at term 0 instead of term 1. So we're calling the first term the 0 term. So you're going to multiply the combination 4, choose 0 by a to the n minus k. Now a is your first term. In this case, a is 3x squared, and b is 5y, because it's our second term. So I'm going to take that 3x squared is my first term, and raise it to the n minus k. So we said n is 4, k is 0. And we're going to take our b and raise it to the k term, which is 0. And anything to the 0 power is 1, so for our first term, really you don't even need to include that second place there. So it's going to be 4, choose 0, times 3x squared to the 4 minus 0, which is just 4. That's our whole first term. And you're going to repeat this process to find all the terms. So our next term, if our first term is 4, choose 0, our next term would be 4, choose 1. And then each time you're going to decrease this exponent by 1 and increase this exponent by 1. Okay, so our 3x squared was raised to the 4th. Now it'll be raised to the 3rd. And our 5y to 0 was raised to the 0. Now it's going to increase by 1 and be raised to the 1st. And that's going to be our second term. We're going to keep going until we have no terms left. So now it would be 4, choose 2. 3x squared is going to decrease a power. So it was to the 3rd, now it's to the 2nd. Whereas 5y is going to raise one further power. So it's going to be squared. And keep going. We're going to have 4, choose 3. It's going to be 3x to the 1st, 3x squared to the 1st, and 5y to the 3rd. And we have 4, choose 3. There's only one left then, because we can only have 4, choose 4. We can't have 4, choose 5, because you can't take a pool of 4 and choose 5 things. So this would be our last term. Now, this is going to decrease another power, so it would be 0, which is just 1. Keep that in mind. And we have 5y to the 4th. Whew, that's a lot of work, and we're not done yet. So you do have to expand and simplify all this out. So again, it's not necessarily super efficient. It may be more efficient than expanding out like 3x squared plus 5y to the 13th, because that would take a really long time to do by hand. But it's a really cool way to see that we have connections between sequences and combination. Okay, so what I want you to do next is to actually simplify each term. So you're going to have to raise 3x squared to the 4th power. You're going to multiply it by whatever 4, choose 0 is, and repeat this process, but you're going to do this on your own with the video paused. Just a reminder, though, you may want to use this graphing calculator to do those combinations. Have fun! Okay, on your own, you should have got something that looks like this before it was all cleaned up. So what I did first is got those combinations going. And what you should notice is that it's 1, 4, 6, 4, 1, which should look very, very familiar to the Pascal's triangle. Okay, so this is one of the rows of the Pascal's triangle. You have something that looks like this. 1, 3, 3, 1, 1, 4, 6, 4, 1. That's crazy. So if you are choosing 4 things, we're actually in the 1, 2, 3, 4, 5th row of Pascal's triangle. So that's a way you can kind of quicken up this computation, is if you relate this to what we did in class there. Anywho, I basically just use my exponent rules. 3 to the 4th, x squared gives me 81x to the 8th, so on and so forth. Now, I haven't combined everything yet, but I just wanted to check in, see if you got the same work. Then we can just go ahead and multiply things out and make sure we simplify it all correctly. Okay, so I paused the video and distributed all that out. Notice that the y's increase by a power of 1 each time, but the x's decrease actually by a power of 2 because you originally had an x squared. So that's a good way to check your work. You want to make sure you have the same amount of terms you had to start. So let's see, I have 1, 2, 3, 4, 5, which is how many terms I had to start with, so we're good to go there. And look at these numbers. This probably would have been very hard to compute by hand, right? If we had to multiply that 4 times, there were a lot of big numbers, which is another reason, binomial theorem may not be like super efficient, but in terms of like tedious work, it might help you with the computation a little bit easier. I find the most mistakes happen just by watching what you're multiplying. Don't forget any numbers. If you have any questions on that, please come to class. I'm leaving a challenge problem for you to try on your own. Okay, the next type of problem you might see is a question that's a little bit less tedious, and it's to find the 10th term in the expansion, or to find the 6th term, or to find some sort of term. So basically, it's like computing the binomial theorem, but not going through the entire process to find the entire polynomial. Okay. So I know in order to find any term, I'm going to need a combination, then I'm going to need 3x to the 5th to some power, and 2y to the 7th to another power. So we just got to figure out what all that is, and then we'll get our 10th term. Okay, so first of all, I know my n is 13, okay, and I have to figure out what my k is. So if I want the 10th term, remember you're starting at position 0. So I'll have 0, 1, 2, 3. So this is actually 4 terms, although I'm ending at the 3rd position. 4, 5, 6, 7, 8, 9. So let's see, that's 1, 2, 3, 4, 5, 6, 7, 8. 9th position gives us those 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, but we have 9 positions. So when you say 10th term, it's actually going to be 13 choose 9 because you're starting at position 0 with the binomial theorem, right? Our sigma notation here starts at k equals 0. So just keep that in mind when you're computing these. So 13 choose 9 will choose the 10th term. Then all you have to do is figure out what your exponents are. So this is going to be n minus k, and this is just going to be k itself, and that'll calculate the 10th term. So you figure out what 13 choose 9 is, you just multiply this out. You've got the 10th term without having to expand the entire binomial, which this is really why the binomial theorem is more efficient. Okay, I'm going to go ahead and do this in my calculator. You go ahead and do it in yours, and we'll compare answers in a minute. Have fun. Okay, I'm back with my computation. Check yours with mine. I wrote out all the steps. Basically just multiplying, using exponent rules, everything we've kind of done this year, put together combinations, and we are putting together sequences. So this is a really good summative problem of what we learned. And it is a really, really large number at the end. Hopefully I didn't make a mistake. I don't think I did, but let me know if I did. So this is why, again, the binomial theorem may be more efficient, because to compute that number, you'd have to compute all of the 13th power, you'd have to multiply that all out, be really, really tedious. So that's kind of cool. There's some extra kind of challenging problems for you to try here, so I highly recommend doing those on your own, but otherwise, that's the binomial theorem, that's how you use it, and please come to class with some questions. Have a good night.